That's a couple of ways of seeing inside our bodies, but I'm guessing that some of you are already thinking, hold on a second, if we watch TV programs like House or Casualty, very often the kind of pictures that you see there look more like this. They're not sort of two-dimensional, they're slices through the body. We're seeing here the body in 3 dimensions by slicing it up like a loaf of bread. How on earth do we manage to do that? Isn't this all a bit too technical for you young minds? Surely I'm going to gloss over that. Well, no, I want to tell you how this is done, because actually this is quite simple to understand. And in order to understand it, I just want to tell you a couple of words. The first word is just the funny name that we use for slicing the body up like this. It's called tomography. It's got 2 parts to it. The first one, tomo, is a Greek word which means slice, or tomos, slice. And you probably know the word atom. Atom means can't slice, the thing that you can't carve up. So tomo means slice, and graphy is another Greek word which means to sketch or to doodle, or in this case, to make a picture. So tomography is a word that you'll hear a lot in medical imaging, and it just means slicing the body up, taking pictures of slices. Now the second word is a little bit more mathematical. It's a word that you know, it's called projection. This process that we need to understand is one of taking a 3-dimensional object and squishing it down flat. That process is called projection. So when we take an X-ray, the X-ray passes through the body and everything along this line gets squished into this point. That's called taking a mathematical projection. What we want to do is to do the projection backwards. Now that may sound, well, how on earth can you do that? Well, about 100 years ago, this mathematician, Johannes Radon, he said you can do this provided you take a whole bunch of these projections all the way around your patient that you want to see. And it was about 60 years later that this guy comes along, Godfrey Hounsfield, and wins the Nobel Prize for building a machine that would do just that. So let me just show you how that works by showing you what's inside a CT scanner. CT scanner looks like every other scanner you ever saw. It's a big white block with a hole in the middle. But inside a CT scanner is an X-ray source and some detector, and they just rotate around the body. And if we look at one in real life, it looks something like this. So it rotates quite a lot quicker than my animation. Okay, well, let's get on with the business of explaining what's going on inside one of these things when it builds pictures of slices. We're going to make life really easy for ourselves by taking the simplest object we can think of to put in our scanner. And we're going to choose a stick of rock because a stick of rock looks exactly the same. Doesn't matter how you slice it up, it looks the same at every slice. So let's make life a little bit more interesting by putting a mystery celebrity face inside our stick of rock, and let's put it inside the scanner. So we're taking now lots of X-rays as the scanner rotates, and we've got to figure out who this celebrity is from these X-rays. Well, since we got them by squishing all the information in the stick of rock together, let's unsquish them. Let's beam them back as if they were beams of light, and beam them back in the direction in which they were taken. And hopefully where those beams cross, that will give us information about the structure inside our scanner. So we'll add together all these beams as we go. So let's beam them back again, but we'll add them together as we go. And hopefully we start to see some kind of pattern emerging that gives us the celebrity that's sitting inside our stick of rock. But it's not very good. Anybody going to hazard a guess as to who we're looking at there? Cheryl Cole is our best guess so far. Cat from EastEnders. That's the first time that one's been suggested. Could you be right? Well, we've obviously got to do something to clean this picture up. We've got to find out what's gone wrong. Imagine that Cat from EastEnders has taken to wearing nose studs. So when we bung her in the X-ray machine, actually that's all we see. We just see a little blip on our scanner showing the very dense gold nose stud that she's wearing. So when we beam that image back, we just see all these little blips, and they all cross exactly where Kath's nose stud is. And that's the clue as to what's gone wrong. Because if we plot this out as a kind of mathematical function, sure, there's a big spike in the middle, but there's all this crud around the outside. And that's why our image looks so blurry. But now let's take 2 copies of this nose stud picture, just because we fancy it, and beam those back side by side. And now we build up a similar picture. It's got all the crud around the outside, but it's also got a hole in the middle. So now we've built ourselves 2 pictures, which are almost identical, but if we subtract one from the other, all the crud around the outside disappears, and just a blip in the middle is left. And that's Kath's nose stud. That's what we wanted. So what about if we use this trick for the whole image? Maybe we can discover who this celebrity is. Well, let's try it. So this is the original beaming back process, and this is the new fancy improved version. It was a valiant guess, but it is actually Angelina Jolie, who I don't think wears nose studs either, as far as I know. Anyhow, the important thing is that we can build up a slice picture. And if we can build up one slice, then we can build up more than one slice. And that means that we can stack them up in our computer memory. And that means that we can build a fully 3-dimensional model of what's going on inside our bodies. And that's great, because that gives us the opportunity to build all of those pictures that you see on television. We can colour those pictures in. We can render them with our graphics card. We can fly through them. In fact, we can truly see inside the human body. So I want you to remember one thing. First of all, you know how this is done. Secondly, the way to do it is to find a way of making one of those squished images. If you can do that, you can do this. If you can make a projection, you can do that. With that in mind, let's have a look at another couple of ways that we can see inside our bodies.